Okay, today we are talking about the second half of 6.6. This is DeMoivre's theorem and nth roots of unity. So DeMoivre's theorem is for taking a complex number to a power. And in Algebra 2, you should have done the binomial theorem, which allowed you to expand that using the nth row of Pascal's triangle. So DeMoivre's theorem is kind of similar, and it is a complex number to the power of n. Or we could think of that as a plus bi to the n. Or in polar form, let me use brackets this time, r plus cosine theta plus I sine theta to the power of n. Taking the whole complex number to the power of n. So and this is r to the n times cosine n theta plus I sine n theta. So I'm taking my radius to the power of n, and then I'm multiplying my angle by n. Okay. So we've got this complex number, 1 plus I squared root of 3 to the third. Now, if you want to do this by hand, this is not that bad. It's only a third power. You would take all of these and expand it out. Now I'd FOIL the first two, and then I'd multiply it by the third. Okay. It's not that bad, but instead I'm going to convert the polar form and use DeMoivre's theorem. For a third, it's not that bad. For a fourth, it's not really that bad. For an eighth, it's pretty bad. For a 20th, it's rather bad to do it by hand, one step at a time with foiling. So I guess I'll FOIL it quick here. 1 plus I root 3 plus I root 3 plus 3i squared. And that's negative 2 plus 2i root 3 plus times 1 plus I root 3. And that's negative 2 minus 2i root 3 plus 2i root 3 plus 2i squared times 3. And that is negative 2. The middle ones cancel, and that's negative 6 equals negative 8. Okay, not that bad. Using DeMoivre's theorem, for the first one, unfortunately I have to convert, which is a bit of a pain, but that's okay. So 1 root 3. My hypotenuse is 2. My angle, here, this is a 30, 60, 90. That's 60. Or I could say pi over 3. So my polar form, r is 3. I should just fill it in. 3 cosine 60 plus I sine 60 to the third. Not 3, it's 2. My radius is 2. Writing the wrong numbers. Okay, so really this means 2 cubed. cosine 3 times 60 plus I sine 3 times 60. Now, usually I would probably just write that as 180. 2 cubed is 8. Cosine 180 plus I sine 180. I'm going to take this out of polar form. Cosine of 180 is -1. Sine of 180 is 0. So that's 8 times -1, -8, plus I times 0 is 0. So it's just -8, and I get the same thing either way. This was example 5. Example 6 is using DeMoivre's theorem on another one. This one I definitely don't want to do by hand. So when I do the Pythagorean theorem, I get 1 here. So I've got 1. This angle here is, we'll do 3 pi over 4. We'll do it in radians this time. First thing I'm going to do is convert. Cosine, so 1 cosine 3 pi over 4 plus I sine 3 pi over 4. Let's make that bracket again. To the 8th. Okay. That's 1 to the 8th. Big number here. Cosine of 8 times 3 pi over 4 plus I sine 8 times 3 pi over 4. 1 to the 8th is 1. Cosine of 6 pi plus I sine of 6 pi. 6 pi is essentially 0 or 2 pi. So cosine of 6 pi is 1. This is 1. So 1 of the 8th roots of 1 is this. So if I say 8th root of 1 in the complex numbers, among the answers is this, because this to the 8th, oops, is 1. So, yes, these are called roots of unity. Roots of unity are roots of 1. And this is 8th roots of 1 because it's an 8. There are 8 8th roots of 1. There are 4 4th roots of 1, 3 cube roots, etc. So finding them, I can use a little twist on DeMoivre's theorem. So finding my roots of unity are the nth root of r. Actually, this is roots of anything. Roots of unity would be 1. Cosine of theta plus 2k pi over n. So theoretically, I could repeat, there's more than 8. I guess I could go, if I'm talking about polar form, I can keep going around the circle till I've gone around, and I can just keep repeating them. In standard form, or rectangular form, there's only 8. But you get some equivalence with going around the unit circle multiple times. So we are going to find the fourth roots of this complex number. And this time they were nice enough to give it to us in polar form. They're asking us for the fourth roots. So that means root 1 is going to be the fourth root of 5 cosine of pi over 3 over 4. Which equals fourth root of 5. That's cosine pi over 12. We're just going to leave them in polar form for this example. This is example 7. I sine pi over 12. Pi over 3 divided by 4 is the same as multiplied by 1/4. That's pi over 12. That's going to be useful a bunch. My second root of unity, now I'm going to add 2 pi. 2 pi in thirds is 6 pi over 3. I guess I don't really need the parentheses here. So I'm adding 2 pi, and I'm just showing that with the common denominator. So again, pi plus 6 pi is 7 pi. And again, it's going to end up over 12. My third root of unity, now I'm going to enter another multiple of 2 pi, 4 pi, which in this case is 12 pi over 3. And that's going to be 13 pi, and again, over 12. And the last one is going to be another multiple. So now I have to have 4 roots plus 18 pi over 12. So that's 6 pi, 18 pi over 3. And these angles being the same each time makes the second one really easy. Pi plus 18 pi is 19 pi over 12 plus I sine 19 pi over 12. So that is roots of unity. Okay? That's where we start. Okay? That's in polar form. Now we're going to do some in rectangular form. So we're asked for the roots of the cube roots of -1. So we know that z is equal to -1 plus 0i. which means in polar form. So again, I'm looking at this over here, -1. My radius is 1. My angle here is 180 or pi. And I'm asked for the cube roots of this. Actually, let's move this over. Cube root of 1. From now on, I'm just going to write that as 1. Cosine of pi over 3. I sine pi over 3, which is 1 times cosine of pi over 3 is 1/2. Sine of pi over 3 is square root of 3 over 2i. So here's my complex number, but 1 doesn't really do me anything. Again, cube root of 1, just 1. Now I've got to add my 2 pi. Pi plus 2 pi over 3. This one's nice because it's pretty easy addition. So I'm just going to say pi plus 2 pi is 3 pi for the sign here. Oops. I did not want that. I wanted it here. On cosine pi, 3 pi over 3 plus I sine pi. On plus sine pi is 0. And that's just -1. Again, the radius is cube root of 1, which is 1. Pi plus 4 pi. That's 5 pi. So again, that's 5 pi over 3. 1 times cosine of 5 pi over 3 is 1/2 again. Sine of 5 pi over 3 is negative square root of 3 over 2i over 2, not over 3. So 1/2. Let's do minus. Let's just do minus instead of plus negative. And these are my 3 roots. If I cube any one of these 3 numbers, I will get -1. Okay. Now we're going to do the 8th roots of unity. 8th roots of unity mean they all are going to be 1 when I take them to the 8th power. Now this was example 8. This is example 9. This is our last one. So roots of unity mean my complex number is 1, or 1 plus 0i. Or in polar form, 1 plus 1 times cosine 0 plus I sine 0. So z1, again, I'm going to take the 8th root of my radius, which is 1. And I take my angle divided by 8. So that is just 1. That's the toughie. Z2, again, a through to 1 is 1, so I'm just going to write it as 1 for the future. Cosine of 0 plus 2 pi over 8 plus I sine 2 pi over 8. That's pi over 4. So cosine of pi over 4 is square root of 2 over 2. So is the sine of pi over 4. And for the future, I'm not going to write the 1 times. So this to the 8th is also 1. Now I'm going to do the next multiple of 2 pi, 4 pi over 8. This is pi over 2. The cosine of pi over 2 is 0. The sine is 1, or just I. I'm going to show you here that I to the 8th is, so I to the 8th is I squared to the 4th. Remember, I can multiply the exponents. I squared is -1, and -1 to the 4th is 1. That's a pretty easy one to show. The 4th one, now I'm up to 6 pi. I'm just going to stop writing the zeros. And I got to go basically all the way around the circle. So I need to get to basically less, almost up to, but not including 16 pi over 8, because 16 pi over 8 was 0. Cosine of 6 pi over 8 is -1/2. But no, it's not. It's negative square root of 2 over 2. Now I'm up to 8 pi over 8, which is just pi. The cosine of pi is -1. The sine of pi is 0. So I'll circle my answers at the end. Z6. Now I'm up to 10 pi over 8, or 5 pi over 4. Cosine of 5 pi over 4 is negative square root of 2 over 2, plus square root of 2 over 2i. Not plus, minus. The sign is negative square root of 2 over 2 now. Z7. That should be an equals. Now I'm up to 12 pi over 8. And I just keep adding 2 pi each time. 12 pi over 8 is 3 pi over 2. Cosine is 0. The sine is -1. This is negative I, which likewise, negative I squared is just 1. Which is still 1. And Z8, up to 14 pi over 8. There is no ninth because that'd be 16 pi over 8, which when I'm doing this on the unit circle is back to 0, same angle. 1/2, no, not 1/2, positive root 2 over 2. 14 pi over 8 is 7 pi over 4. So I could look at all of these and think of them on the unit circle. Probably easiest to think of them in angle terms then. I'm going to circle 1. Again, x, y. 2, 3, 1i. 4, 5. Notice the repeated pattern of every 45 degrees. We get another one. 6, negative I is 0, negative 1. Those are my 8 roots of unity. They all have radius 1. All of these have 1 for a radius. We are on the unit circle. And we've got 8 evenly spaced points. And that is DeMoivre's theorem and roots of unity. And that is the end of 6.6.